Based Class 3470 Application and Server Support Digest 2 Core Network Services. Due March 14th, 2018. Prepared by Noor Amin, Ryan Matthews, Colton Rumbold, and Stefan Susi. Prepared for Thomas Rayner. The purpose of this lab will be to explore the various core services we can expect to see in an enterprise environment. In this video, we'll be covering both proprietary and open source options for clustering servers and services, hosting a website through a web server, and data collection through the use of database servers. For our proprietary software option, we have chosen to build our network using the Windows Server 2012 R2 operating system, while for our open source alternative, we will be using the CentOS Linux distribution for some of our servers. Now, let's explore the various services that we set up in this lab. In the first section of this video, we will be discussing the topic of high availability for our servers. This is for when one of our servers goes down, a separate server is able to take control of the service it had running and keep it operational on the network so it's still usable by all the clients that we have. First, let's take a look at the Windows side of our network. The first clustering service used in our Windows environment is the Network Load Balancing tool. This will be used by our web servers, so if one of them goes down, the other is still capable of hosting the website to the devices in the network. We assigned our cluster to have an IP address ending in .55, and as we can see, both high availability servers show up in the NLB cluster with their respective IPs. We will explore this feature later in the video. The more common clustering service used in Windows servers is called the Failover Cluster Manager. This tool allows for the clustering of services such as DHCP, DNS, and file servers. On screen, you can see that our cluster was created and that it has an IP address ending in .56, and that both of our high availability servers are a part of this cluster. In terms of networking, we have network adapters that connect not only to our client network, but as well we have a .40.x network that connects to our Heartbeat network. This is for the two servers to identify if one is down and the other isn't, which is why it has the cluster use of cluster only. We also have an interface to our .20 network just so that this server can communicate with all the other devices on our network. We have set up a file server between our two servers, and as it states on screen, HA2 is the current node owner for the cluster, meaning that because we are on the HA1 server, we cannot see the data drive that we have on our cluster being shared. On HA2, we can see that the data drive is currently present, and we will only be able to see it on HA1 if we make HA1 the primary node owner of our cluster. Once it has become the active node, it will now be able to see the data drive. In this part of the video, we were planning to demonstrate how the failover service works with the file server, but unfortunately we ran into a complication with one of our servers where it became unable to ping newly introduced IP addresses on our network which were created by the clusters that we needed for our file server to work. Now that we have seen how high availability works within a Windows environment, let's see what happens when we take a look at our CentOS environment. For clustering on our CentOS devices, we have decided to use the Pacemaker application to better coordinate between our nodes and establish Heartbeat connections, while CoroSync is used to move the configuration and services between the servers. The command PCS is used to configure both of them. First, we can see the name of our cluster, CentOS Cluster 3. Then we can see the two nodes that make up our cluster specified by their host names. These hosts are set up in a host file so that the Heartbeat will use the correct interface on each device. We use the short name and the FQDN to associate the Heartbeat IP address to each node. When we look at our CoroSync configuration, again we can see the nodes that make up our cluster as well as the resources being shared between them. We can see information such as our virtual IP, which is the IP address our cluster resources will be accessed from. In this case, we'll be using 192.168.20.35. We can also see the file systems which have been mapped through iSCSI logical volumes to /var/www, which is where our website and other files will be saved. And finally, we can see the HTTPD daemon which serves the web content. We used Apache in our case. We can also see that the specified configuration file for each node's instance of HTTP is configured on each node. They also use a loopback address to monitor their own status, which is communicated to each other through the Pacemaker application. For the second section of this video, we will discuss the different web server applications that we installed on each of the servers running different operating systems. For our Windows environment, we will be discussing the management and configuration that we used to create our IIS web servers. The IIS management page provides us with lots of opportunities to configure our website in many different ways in order to better suit our clients. For file and directory exploration, we can use the basic settings of a web page to see where we'd like to load our web page for our website from. We can navigate to the files, load them on, then after that we just simply have to restart the IIS website, and then from there they should be able to be explored by any web browser. We also may need to examine the application pools for our websites just so that we can properly configure which user accounts we want to run certain services. In our case, we want our ATS administrator account to be running our HA1 website so that when we communicate with our database server, it is connecting with ATS administrator instead of a standard IIS account. Lastly, IIS even has its own little option for us to configure our SSL settings by enabling them onto our device. Next, we will show what our final IIS website that we configured in Visual Studio will look like. It shows all the required information, however there is no secure sign-in implemented in order to gain access to the employee database form. We will now show that we have SSL set up on both of our websites for both servers. If we open up the HTTPS link to the website on HA1, we can see a small lock icon in the URL that indicates that SSL is functioning. Within this lock icon, we can view various informations about the certificate, like how DC1 is our current certificate authority and is the one that is handing out the certificate information. The same goes for HA2, as when we go to its HTTPS website, we will also see the same lock icon, which is representing that SSL is functioning on our site, and that DC1 is our certificate authority handling all of our certificate information in our network. We will now show how we enabled high availability within our web servers and our Windows network using the network load balancing utility. For the purpose of this demonstration, we set up 2 local websites on each server that leads to a page which defines which server our website is currently being hosted on. This will allow us to better see how our high availability is working after we fail over a server. As you can see, when our client goes to our website, the website shows which web server is currently being used to host the website, in this case, HA2. If we suspend the NLB service from HA2, we will see that HA1 will become the new active node. Now when we browse to our website, we will see that on the page that it is being hosted by the HA1 server. Once we restart the NLB service on HA2, it will fail back and become the regular active node. For our Linux servers, we decided to create an Apache web server that was both highly available and was able to give us direct access to our database server to enter in our forms if needed. When it comes to managing our Apache web server, our methods were quite simple. Apache has no web portals or applications for us to configure our web server, so we need to rely on the use of other tools. To manage the files on our web server, we needed to use SFTP to transfer files between our active node and the workstation that we were using for editing the server. When it came to editing the code that would make up our website, we decided to stick to using Notepad++ to function as our code editing suite. To manage any permissions, we use an SSH session with the active node to modify the configuration, permissions, and anything else we needed in order to get our web server up online. And that covers all the tools that we use to manage the creation of our website on our web server. Unfortunately, we were unable to configure a secure login for our web page's web form link. We have very little experience in web development, which led to difficulties in creating a secure login to access the employee database. It was one of the few requirements for this lab that we were unable to meet. When browsing our website, we can see that we do have a secure access via HTTPS, as the SSL certs are valid and issued by our local certificate authority. We will now test the failover capabilities of our Apache web server. We can see here that the cluster is live and that all the services are being hosted on Node 1. Both nodes are currently online and Node 2 is the decision maker in the cluster. We also have a continuous ping in the bottom right hand corner to the virtual IP to show we have connectivity. We can see that we can access the website while Node 1 is operational, so let's simulate a failure of Node 1 by pausing the VM and watching as it fails over to Node 2. In the bottom right corner, we can see a single ping timeout to the server, and we can see that the active node is now set to Node 2 on our web server. When Node 2 is the active node, we can still click on the employee database and access the contents of our web server. We will now resume the role of Node 1 to simulate a recovery for if the server was turned back online. We can see that it does take some time for our Node 1 to be detected by the PCS service again, but when it does, we can see that our resources are temporarily live on both nodes and will eventually all be moved over to Node 1. After this recovery, we are still capable of accessing the database afterwards with almost no interruption and no form of lost state information. This means that Node 1 is now hosting our web server again, and that the failover of services is working on our servers. In the last section of this video, we will be discussing how each database application works, as well as providing a demonstration on how we set up our database servers to collect the data from our web servers. First, let's discuss how we used a Microsoft SQL server to create a database on our database server. There are many different areas to explore when using Microsoft SQL. You can see that when you sign in, you have a choice to choose between either Windows authentication or signing in with an SQL service account that you have created. Speaking of accounts, you can configure the access to your SQL database within the Login section underneath Security. By clicking on a user, you can view lots of important information that pertains to both security access as well as information such as permissions set on each account. There is also an option to view the various server roles available on the server, which define what kind of access a login account will have on the database. We can easily manage any databases we have created by simply going to the database dropdown and clicking on the database that we have created. We can then view the different values within this database. If we select one of our tables, right-click it, and choose the top 1000 rows, we can see the most recent items that have been entered into our database from our web form, as you can see on screen. This is not just reserved for tables, but any other data values that you have entered within your database will also be able to be found here and managed accordingly. On screen, we have an example of us entering values into our web form that's being hosted on our web server. As you can see, it is asking for the various employee information for Mike Hunt. After filling this information, we can then later check our database server and see that all the entries are currently present at the latest row within our table. This shows that our web server was able to insert this data into our current database table. The last thing we will cover with Microsoft SQL is how to either compress or back up a database, which is actually a fairly easy process. All you need to do is right-click your database, select Tasks, and then choose your choice of either compressing the size of your database or backing up its contents to another location. This will cover everything we'd like to discuss in regards to Microsoft SQL. For our devices running CentOS, we chose to use the MySQL database application in order to create a database for our Linux servers. To manage our SQL database, we will use the MySQL console being ran on the database server. The commands shown here were what was used to configure our database. The first step is to actually configure the database and set ourselves up working in the database directory. From there, we will create our employee table in the database, setting up columns of information such as names, types, lengths, as well as configuring a primary key. After that, we need to set up remote access to get into our database. We first need to edit the configuration file to allow the SQL daemon to bind itself to any IP address other than the localhost IP. We have to grant permissions for remote access. This is done by using the 3 grant commands shown on screen. We decided to grant access to each node within our network and for the cluster's virtual IP, as we weren't quite sure which would be used as our active node. On screen, we can actually see where the actual database file is being saved on our database server. We can see the table and its contents stored. This way, we can configure it to move the database elsewhere if needed, such as to a high-speed storage device. On screen, we can see an example of us adding a new employee to our Linux database using the web form hosted on our CentOS web server. We'll be calling this user Tom Thumb. We can see that he shows up in our employee master list. We can also check our MySQL console that's running on our database server to view the database table information directly, where we can see our new entry for Tom Thumb. To compact our database, we open up the MySQL console command and access the database by using the use and then the name of the database command. We can now begin to compress our table, which on Linux is called optimizing, in order for us to save space on the server. In this case, this feature is not supported, but there is a form of optimization being completed. To back up our database, we simply use the MySQL dump utility, where we specify which database we'd like to back up and then specify an output file. We use MySQL instead of a file-by-file backup because our dataset is quite small. We can break up our backup to individual tables if we wanted to using the MySQL dump command. The MySQL dump utility essentially provides us with all the commands needed to recreate the database from scratch if necessary. This way, we can make our database files more portable to other database management servers if needed. This should have covered everything we'd like to discuss about Linux-based database servers. Thank you for taking the time to watch our video. We hope this video provided you with enough information to get a better understanding of the different core network services available out in the market. Until next time, see you then.